for the invite, and thanks everyone for joining me today. As mentioned, my name is Riley Rouse. I am a research technician at Michigan State University in the horticulture department. I'm going to be speaking a little bit about the research that we do, specifically in our tree physiology lab. You see another name on here, Dr. Bert Craig is my mentor and supervisor, and he's really the one that leads the charge on all of this. I just get to do the fun work outside and get to talk with groups like you all to kind of talk about what we do. So you'll see Bert in some of the photos, and I'll refer to him a whole bunch. So some of this work kind of predates me, and I'll speak on what was done prior to me joining the lab as a graduate student in 2018. And a lot of this relates to my master's thesis research, and then I was fortunate enough to stay on as research technician, continuing to work with Bert in the same lab. So I had to have a catchy name here. Like I said, we're going to be talking about approaches to fixing circling roots, different approaches that you may have heard of, including root slicing, shaving, and a newer one being promoted is bare rooting container stock. So have to go slicing, shaving, and bare rooting. Oh my. Let's see if I can get my slides to progress, then we'll be good to go. Uh-oh. Always got to get a couple technical difficulties. There we go. So I'm going to make everybody smaller there. Perfect. So just an overview of what we're going to be talking about today, why some of this research is taking place at Michigan State, and I'll say that is to improve transplant success, specifically of container trees, and then I'll be talking a little bit about why we do this research on container stock. Of course, as good scientists, we had to dive into the scientific literature a little bit and see what's out there as published experiments. And like I said, I'll be talking through kind of a decade's worth of studies at this point that our lab has conducted, looking specifically at some of these different approaches. And we'll summarize that and talk about where we want to go with all of this. So my slide here, I always laugh. I'd say this is an obligatory slide for anybody giving a tree talk. We have to talk about, we have to really rewind and say, why do we care about trees? And fortunately enough, a lot of the public and those making decisions are more aware of the benefits of trees these days. And namely, as I said, we know that there are ecosystem services provided by trees, be that stormwater mitigation in urban areas, energy savings, they improve our air quality, carbon sequestration. It's just a few of the great things that trees do for us. They mitigate urban heat island effect. They just provide shade on a hot day. Of course, they increase our property values when we have ornamentals planted outside our home, and there's just a slew of studies that show that our mental and physical health is benefited by green space in our urban areas. So, like I said, have to put this slide in there just to say trees are great. That's why we want trees. But then there's also a need for better planting practices. I say that because there are all kinds of pushes for, million tree planting or 90% canopy cover in an urban area. It's a little bit of an exaggeration, but, we have all of these pushes to plant more and more trees, but, are we necessarily doing it effectively? There's a little bit of aftercare involved in the trees, and we want to make sure that we get the trees in the landscape in a way that's going to benefit them in the long term, because a lot of these ecosystem services that I just mentioned, those aren't going to be maximized until the trees reach maturity. And unfortunately, I think the average lifespan of an urban tree, a lot of the time, the number that's talked about is only 7 years. So like I said, we need to plant these trees in a way that's going to get them to survive and really maximize those benefits. And then there's also a need for increased species diversity. There's been too many monoculture plantings where they might look great from a design perspective, but we plant all elm trees along our major streets, and then something like Dutch elm disease comes and wipes out our entire canopy. Or let me see if I got get my pointer going. I guess, can you guys see my cursor? I'm gonna hope you can. But up here in the right hand corner. Yes. Thank you. We've got emerald ash borer, and you can blame us in Michigan here for the reason why that was, it was introduced into Michigan, 2 decades ago at this point, but here's an ash tree. That's a really good looking ash tree if you're in Michigan, but just another example of these invasives are coming, climate change is coming, and that's why we really want to promote understanding species differences and just promoting increase in species diversity when we're planting trees. So like I said, why are we talking about container stock at all? Well, container production is increasing. It was believed the 2012 USDA horticultural census noted that I think over 60% of deciduous shade trees were being produced in containers. It's $1 billion industry. We like container trees, but those of us that are planting them, they're lightweight, they're easy to move around, they're easy to put a bunch in the back of a truck. A lot, like I said, lighter than trying to maneuver around a big B&B tree that's got a big heavy root system that you might need specialized equipment for. These are good. The nurseries like them because they can be produced on less fertile soil because they're in their own container media. I said they can pack a bunch on a truck and they ship pretty efficiently. So there's a number of reasons why container trees are a great option. However, they have their drawbacks. And I don't know who got too silly at the nursery and did this, but I love this picture to show that, circling roots are a huge issue, and just malformed root systems in general, because containers do affect the root development. Makes sense, there's only a limited rooting volume. As that tree sits in the container for maybe too long in the nursery, those roots are going to attempt to grow laterally in the container, and they're going to hit the side wall of a plastic container, and they're just going to circle. They have nowhere else to go. So you end up with this really dense root system that is not what we would want. If we were to grow a field grown tree, or if we're walking through the forest, we see sprawling lateral root systems into the surrounding soil. And that's really what we need to see to get these trees established. So like I said, the poor root architecture is caused by, I have BP there, so I call that a standard black plastic nursery container. And those root defects really can inhibit, again, the establishment, because you're just not getting that lateral root egress. So the roots are going to probably continue to circle if we don't do anything about it. It can choke out the tree if we get stem girdling roots near the trunk of the tree. And also it's just unstable. The tree is more likely to tip over because it's not getting established. If there's a high wind event, the tree is just not stable in the landscape. So got a little example here. Like I said, the roots are going to continue to circle if we don't do anything about it. So, that's likely an imprint from an original nursery container that it just got plunked into the ground like that. And we see this all too commonly. I have a couple examples here. It wants to load a little slow. That's okay. There we go. This is more of an example of a stem girdling root. Like I said, when you get these circling roots growing closely to the trunk, the trunk's going to increase in diameter over the years, as are the roots. And so there's going to be compression on the stem there, and it's going to effectively choke out the tree by constricting the xylem. The water's not going to be able to move throughout the tree. And so that's a big issue. And then that becomes such a weak point that even if the whole root system didn't give in a high wind event, the tree would probably just snap right there, and it would end up being a failure. So like I said, the things I'm talking about today are really approaches that we can take. If we buy a container tree, we get it to the planting site, we take the container off, and we're like, oh my gosh, this is just a mass of roots. What can I do to really remediate these issues that have already kind of it's a little too far gone. The nurseries produced the tree this way. We bought it. We didn't notice that it was an issue. So we're kind of stuck with it. What can we do at the planting site to remediate some of these issues? But I do want to note that there are alternative containers out there. This is getting more and more popular. Like a lot of industries, the nursery industry can be a little bit slow to change, just kind of the nature of the industry. But there are other things out there. There are fabric grow bags, different trade names, root pouch, root maker, other plastic containers that have holes in them. They're generally termed air pots, or different air pruning containers that when the roots are exposed to air, the root will stop growing at that point, so they won't continue to circle. There are a lot of other alternative containers available in the nursery trade, but not as available as your normal smooth-sided plastic container. And these might be a little bit more expensive just for a number of reasons. You might still be stuck with a tree that was grown in a standard nursery container and has a mass of circling roots. But I do want to note that there are other things out there, and hopefully the industry is going to continue to utilize some of these alternative containers. But right now, we're going to talk about what can we do if we do have just a nasty amount of circling roots in our root system. So one of the practices is looking at slicing the roots. Just this makes sense to us kind of on a level where it makes us feel better if we kind of just take our spade or knife and just kind of chop through the outer circling roots just to kind of disrupt them on the exterior. It's more intuitive. There's just kind of like, hey, if we cut through these, maybe there will be some new root growth outside of this initial root system, which can be true. There have been some studies that have shown that this is beneficial. And then, of course, like most scientific techniques and experiments, other studies have shown that it's not necessarily super beneficial. But this is something that I think, talking to my fellow arborist friends and practitioners, I think this is something that's happening a lot in the nursery, because again, it's intuitive. It makes us feel like we're doing something. Another one that I think is an intuitive one is teasing the roots. This is literally just manually manipulating the root systems, whether there's a garden fork there or we use our hands. We've all done this. I think if you buy a flat you're planting annuals outside, you pull up the little annual out of the flat and you just kind of naturally want to break up the roots at the bottom of that plant. This is another one that it's like, oh, we feel like we're doing something, which I think we are. There have been some good results in teasing, but as we get to bigger woody landscape trees, this can be quite time consuming. And it can just be difficult as those roots begin to, like I said, become woody or more structural roots. They don't necessarily want to bend where you want them to. You can bend it and pull it out of that mat of roots. You can pull them out, but they kind of have a tendency to want to snap back. So if you have patience and a good crew of folks with you, you can do this, and it can certainly be beneficial. But again, it's just a little bit time consuming. And this is one where, like I said, some of my arborist friends might roll their eyes just saying, we know it's a good thing, but logistically, it's just a little bit too time consuming. So, but this is another technique that's out there. And then what really got the bulk of the research started in Dr. Burt's lab that I'm going to be talking about, there was talk coming out of shaving the root system. So I don't know how many folks have heard about this, but this is one that's really gaining popularity. So when I talk about shaving the root systems, I'm talking about just removing the entire periphery of the roots on all sides and the bottom. You can see this is a good graphic here of just taking a saw, or again, you can do it in the ground with a sharp spade. But we use a hand saw just to take cut all the way around the roots. And then you can kind of see peeling back those circling roots, you're going to have all these little cut roots exposed. And the theory there is that new roots regenerate from cut roots. There's, again, you can kind of see in theory on the left, and then in practice of what we've seen on the right. If we cut through a root, that point is going to form a callus, and new roots are going to regenerate from right behind that cut point. And hopefully what we want to see is that they're going to be a little more outward rather than continuing to circle. So we're going to be talking about some of these techniques to where we've kind of put them through a more rigorous experimental design and are able to kind of compare what we think about some of these techniques. And I'll talk about a few other ones as well. So like I said, talking about a series of studies. We looked at different techniques, different species, and we'll go through all of those here. But the overall goal of all of this research, to go back to the point of this talk, is to improve tree establishment and really improve transplant success, specifically of container grown shade trees. So starting in 2012, like I said, this is what predates me in the lab a little bit. So I'll refer to we, but I really mean Bert and his former crew. But in the lab, they established a kind of a dual trial, two separate experiments, if you will, looking at specifically the shaving technique of London plane trees. And so we're using pretty large caliper, they're like 25-gallon container trees, pretty good size shade trees that we're putting into the landscape. So the first trial involved involved shaving and teasing, and then also looked at true fertilizing at planting. So I won't touch on that other portion too much, the fertilization, but um, we don't usually recommend fertilization at planting. And then, kind of spoiler alert, we still really don't. The thought there is that the trees come out of the nursery pretty hopped up on fertilizer, and they don't necessarily need fertilization right at planting those first couple of years, because they're so babied in the nursery. They're really well taken care of there, so they don't usually need a lot of extra fertilization. But what I'll be talking about is more of the root treatments here. So this is our control treatment. I'll walk you through kind of how these were done. Um, for better or worse, this is like, we call it our plop and drop treatment. The tree went into the landscape looking just like that, no root modification whatsoever. Just the hole was dug and the tree was plopped in. That's the control. So we can compare, of course. And then we did the manual teasing. As you can see, this is Dr. Burt here. He's got a garden fork, and he's got a plane tree there that he's just manually trying to break up that root system with the garden fork and with his hands at different points to really pull those roots out and straighten them as the trees were getting planted. And then here's a little bit of better depiction of the shave treatment. So you can see a handsaw was used. This is that bottom pancake layer, as I call it. That was shaved off of the bottom of the root system, and then the entire periphery was shaved off. So you can see some media and some scraggly roots laying around, so that new cut roots, I should say, are exposed. And then the theory, once again, is that those new roots can grow a little more outward. So those are the 3 root treatments. And I have a figure here that's looking at caliper growth over a couple seasons. So stem diameter growth as the trees were growing in the landscape. So after 2 years, like I said, fertilization did not affect growth. So that's why we don't necessarily recommend it. Wasn't beneficial in this case. But then also we can see we're looking at the difference among the shave treatments, and this might not look all that exciting, but this was kind of a no news is good news type of figure to see. We thought maybe by removing so much root biomass or root area, you're really disrupting the root to shoot ratio. There's still all of that growth on the top of the tree, but we're removing so many roots. So there was a concern that we may negatively impact growth. But in this case, the shaving, because we removed those roots, did not negatively impact the caliper growth. So after a number of years, we went ahead and dug up the trees and got to really investigate the root quality. So this is kind of the meat and potatoes. This is the stuff that I get excited about. It's like, okay, so the trees grew all the same, no big deal there, but what did the roots look like? Was this a beneficial technique? And pretty shockingly so, both the shaving and the teasing drastically decreased the percent of circling roots. Now, this is just looking, someone looking at the root system and trying to somewhat quantify what percentage of the root system is still circling within that, original nursery container. So, a control, you've got almost 90% of the roots still circling, whereas you've first of all dropped that to 0% of the roots are circling if you tease them, and nevertheless 13% of the roots are still circling when you shave. So this is after 3 years in the landscape. So pretty stunning results to see such an improvement in root quality in response to taking the time to perform some of these treatments. And then, like I said, this was kind of a 2-part trial. So the other portion, not instead of the fertilizer, looking at using mulch. So the treatment was with or without mulch, and then also the control, the teasing, and the shaving. And this was at a different site to get a little bit of a different idea of, how are these trees responding in different soils. So again, these were left in the landscape for an additional year, but root ball modification did not have any effect on caliper growth. So another no news is good news. We didn't harm the trees by removing any root biomass. And I don't really talk about it here, but I will just make the comment that mulch is good. You should mulch your trees. There were benefits to mulch. There was more growth of the trees that were mulched. So that's more of a soapbox that I could go on and on, but we do recommend mulching your trees. Don't recommend fertilizing, but we'll stick with the root stuff for today. So in that portion, that trial that was done at the other site, again, stellar results of, over 75% of the control root systems on average were continuing to circle. Whereas at this site, shaving was awesome, teasing was awesome. You virtually eliminated circling roots when performing these techniques and leaving these trees in the landscape for a couple of years. And then just visually to give you a little bit of a better idea, I think even if I didn't have this label here, y'all could probably assume, hey, that's a control tree. It's just, and this is probably a pretty good looking one where we did have some outward root growth. But essentially the roots continued to circle, got a little bit of outward growth. But then when I show you this, I think that's a much higher quality root system. When I'm looking at that, you're seeing no circling roots. This is in response to shaving, as it says. I don't have a photo of the teasing, but very similar looking results where ton of outward growth, no circling. That's a root system that I would be super happy with when I was planting a tree. So all of that led to Bert wanting to continue to kind of build a framework for these recommendations. He's a pretty skeptical scientist, which is a good thing, but was initially looking at the shaving technique with skepticism, just saying, is this going to be damaging? Is this going to be worth it? And was blown away by those results, as I said. So wanted to continue to look at additional species, look at some different methods. And this is when I started working in the lab in 2018. This research that I'm going to be talking about right now was the bulk of my master's thesis research. So I'll walk through some of the techniques that we looked at. So something that was really gaining popularity at the time was the notion of bare rooting container stock or B&B stock, but we're gonna be talking about container trees here. So of course you can buy bare root trees and that's a popular stock type. There's advantages and disadvantages there. But when I'm talking about bare rooting today, I'm going to be talking about taking a container tree and removing all of the substrate container media that was within there. And that allows you to really evaluate the root system. Without that media there, you can go in and you can manually, take your pruners like it says here, and you can make any root corrections that you need to because you don't have that media in the way, and you can go ahead and more finely manipulate the root system. So like I said, that was gaining in popularity in the recent decade. There's been some work out there, more preliminary studies that have said that bare rooting is really the only means to reveal those root defects, like I said, because you're not blocked by the media. You can really get into the internal root system and go ahead and make any corrections that you want to make. So this is one of the treatments that we wanted to look at, and I'll go a little bit more into depth and show you our methodology in a moment here. But like I said, Bert also kind of wanted to build this framework, knowing that trees respond differently, different species, I should say, respond differently to, all factors in the environment, and then external treatments as well. So as the previous study was done solely with London plane trees, we wanted to add a couple other common landscape species. So we used the same large 25-gallon containers, but we looked at 3 species. We did red maple, tulip tree, and London plane tree. And then we also wanted to look at timing effect, if you will, seasonality of performing these treatments, because another benefit with our container grown trees is that they're available all throughout spring and summer. A lot of the times when we get a B&B tree, those are more available in the spring or the fall, at least in the temperate region of the Midwest where I'm coming from today, is that's when the trees are available, because that's when the nurseries are lifting those trees. So instead of just making a blanket statement of you should do these root techniques on container grown trees, any species, any time of year, this specific experiment allowed us to kind of start teasing out any potential differences and again, just hone in on what recommendations we're making. So the bulk of the trees were planted in spring, and there was a smaller subset that we planted in summer to look at that. So just to kind of explain again, of course, we always have a control treatment. That poor tulip tree got plunked into the landscape. as is, no root modification whatsoever. That's our control. Another depiction of the shaving here is, you can see removal of that bottom matted layer. That is just crazy. All those roots kind of forming on the bottom of the root system there. That's removed with a handsaw, and then the entire periphery, about an inch on all sides, we go ahead and cut off. And that's the shave treatment once again. And then we did 2 different bare root treatments. So again, bare rooting is the actual removal of the container substrate. So we use the air spade. It's just a pneumatic air tool, like a super high pressure, just like I said, air tool. It's just high pressure air coming out. And that effectively just blasts away the container substrate. And then you're left with this, which this is a red maple. So it looks a little wiry because they were just so stinking dense to begin with, but no container media in there. And then we could go ahead and take our pruners and remove anything that was circling or malformed. And then the other approach we took to bare rooting was what we're calling our bare root wash treatment. And these trees got to be a little spoiled. They got to hang out in the tree spa overnight. The thinking there of soaking them in water was to kind of begin sloughing off the container substrate, which in theory, these trees were so stinking dense that I don't know that it made much of a difference, but they got to relax. And then the following morning, we just used the stream of water from a regular garden hose to, again, just blast out that container substrate. And then we went in and, like I said, manually root pruned. So here's an example. We were very aggressive in how we went about our root pruning. We pruned out anything that was circling. So just an example here, you can see, that root that arrow is pointing to was chopped off with my Falcos, and that resulted in the removal of all of these fine water absorbing roots. And it was almost kind of grafted on there. And so this slide is really just to show you that we were aggressive in what we took off. So we were definitely modifying the root to shoot ratio with this treatment. And this slide is really just to show that, again, all these things take time. We've got scientific names here, so I'll run over. Acer rubrum is our red maple, Liriodendron tulipifera is our tulip tree, and then Platanus X acerifolia is the plane tree. So I may have some of those scientific names sprinkled in through here, but this is looking at the time that these root treatments took. Just in minutes of how long did it take to plant the tree, get it in the ground. So a control, we can plant a tree depending on the species, it on average 5 to 7 minutes. The shaving, this was our first go around, my first go around, and the undergraduate students that work with us, their first time doing this. So these things might be able to be sped up, but again, this is just a first go around. It's going to take a little bit longer. So the shaving, again, depending on the species, took about double the time, 10 to 15, 20 minutes to perform the shaving. But then when we get into the bare rooting, we can really see this is where it could take a long time to remove the container substrate and then go in and prune out anything that you need to. Again, we're doing this in a scientific, I should say, systematic approach where, we need to have it so methodical. We need to do things consistently. So we're trying to get every little piece of container media out of there. If somebody wants to try this out, they might not have to be as strict in their methodology. So maybe that's why it took us a little bit longer, but I just think it's important to note, again, I have arborists telling me, hey, this is awesome, but it takes too long. I don't have the labor. I don't have the tools to do it. So that is something that we want to be mindful of as we make some of these recommendations. So the first thing that we started to notice couple weeks following the first spring planting was a lot of dieback on the trees. And so this is a columnar tulip tree. That's what we had out there. So makes kind of a good graphic here to explain our rating system. We went ahead and just had a qualitative rating system, 0 to 4 for the amount of leaf scorch and dieback on the trees. So pretty obvious, a 0 is a happy, healthy tree with no leaf scorch. A 4 is a dead tree. It is crispy and has totally given up. Whereas a 3 is kind of in that zone where it probably just wishes it were dead at that point. There's significant dieback. And what we did from that point was go ahead and lump our 3 and 4 ratings together and to describe that as exhibiting extreme leaf scorch. So as we move on here, we're looking at the percent of trees in each category or that received each treatment that are exhibiting that extreme leaf scorch. And we did this a couple different times throughout the first growing season. I'm showing 2 of the dates here. We've got June 14th, which was about a month after planting. And then by the end of the first growing season is our September date. And what I really want to show here, starting looking at our early date following planting, is that, the control trees across the board weren't exhibiting that leaf scorch. Okay, we keep these trees watered, they're mulched, they're not, we provide supplemental water when it's needed. So across the board, the trees are watered. I'll go ahead and say that. It was interesting to see that in response to the shaving technique, 2 of the species were not necessarily affected by that one, but the tulip trees really took it hard, and about 40% already of the trees were showing that extreme leaf scorch. And then even getting into the bare rooting, things varied widely across species, but you can see that the bare rooting with the air spade was negatively impacting the tree. About a quarter of the maples and the plane trees were exhibiting that extreme scorch, but the tulip trees, over 3/4 of the trees were showing dieback, or they were already dead. I'll go ahead and say that, which was pretty surprising. And the washing, similar trend, might not have been as detrimental as the airspace treatment, because the airspace may have caused a lot more desiccation than using the garden hose. However, 50% of a couple species, 40% of the red maples were exhibiting that extreme scorch. And then, but it was interesting to see that some of the species continued to decline. Like I said, the tulip trees, by the end of the first growing season, all of those trees were still exhibiting scorch, and even more were exhibiting scorch at that point. Whereas the plane trees, all of the trees that were initially exhibiting leaf scorch had recovered. And so that's where we're starting to see a lot of these, pretty obvious differences in how the species are responding to our different root treatments. So that was an interesting thing to kind of initially see as we're walking through the field. And then this is another just indication of did we were these treatments detrimental to the growth of the trees? Again, pretty much no news is good news, except for this is showing stem growth and height growth over the course of 2 growing seasons. The stem growth of the red maples that underwent the bare root wash treatment were a couple millimeters smaller than their counterparts that received different treatments. So that is the only place there was a very slight negative impact of removing some of that root mass. But overall, big picture, again, not really negatively impacting growth of the trees when performing these treatments. However, what's really most crucial to look at, I think, is the survival of the trees, or the contrary, mortality. The trees, it varied by species. Some species were really tolerant of these methods, whereas some weren't. If you look at our red maples on the left here, we lost a couple of trees. I kind of call this random death. We lost a control. We lost a couple of the bare rooted trees. Jumping to the right here at our London plane trees, which, if you recall, it was used in the initial experiment, none of those trees died. Even whatever we put them through, they all survived the 2 growing seasons that they were in the landscape. Whereas, pretty shocking, again, our tulip tree is showing to be quite sensitive to any root modification. No death of any of the control trees, whereas a few trees died in the shaving and the washing treatments. And then again, that air spade treatment just proved to be way too harsh. And for whatever it's worth, this is only one of the 8 replications of the tulip trees that underwent this treatment survived. So way too harsh. But again, this at least gives us an idea that, hey, yes, there are species differences. Let's hone in on this before we go ahead and just make all these blanket recommendations on these different treatments. I'm not going to spend a ton of time getting into this slide because it's a little small and a little difficult to read, but this is looking at shoot water potential of the trees. So what you really need to understand here is that a higher number is less stressed. As we drop down to a lower a number, that's a more moisture stressed tree, if that makes sense. So this is looking at several dates throughout the first growing season and then into the second growing season, where we have equipment that can measure the stem water potential of the tree. And what's important to note once again is that a lot of the differences in water potential are occurring right after the trees are planted. So those first couple of weeks are really the crucial time after planting, when the trees need to be able to take up water and just stay well watered so that they don't continue to decline. As you can see, like I mentioned, a lot of these differences, this is the tulip tree here. This is where we're seeing a lot of differences in plant moisture stress. And some of the trees were able to recover overall, whereas this is that bare root air spade treatment. All but one trees was already dead by the middle of the first growing season. So we didn't even continue to monitor those because there was one left and you can't do anything statistically with one tree. So that just dropped off. But if we look at the other species or the other treatments of the tulip tree even here, all the trees across the board on average that received the different treatments, they were tracking right along with the control trees. Even a month or two after planting, they had all recovered, if you will. So all of this to say, once again, this is a little in depth, but the crucial timing of keeping the trees well watered and having the trees be able to take up water are those first couple weeks after planting. But the trees can recover following some of that initial moisture stress. And so all that stuff that I was just talking about was the trees that were planted in spring. I'm just going to really quickly buzz through a little bit of our summer results here. We went ahead and dropped the bare root air spade treatment because we saw how detrimental it was and how it was just a little bit too harsh of a treatment. So we went ahead and used all the trees that we had and broke it down across having a control, doing the shaving, and then our bare rooting was just with a garden hose. And so again, these trees were planted in July opposed to May. So for us, pretty much hottest time of the year, driest time of the year. Again, even though we provide water, there are other things that take place when the air is dry around the leaves. But what this is showing is that even our tougher species, if you will, the plane trees and the red maples, even those kind of took a beating in response to some of these root treatments when planted in a more stressful time of year. The tulip trees, interestingly enough, there was no mortality in response to the shaving. However, none of the trees that were bare rooted survived. So this just kind of continues to play into our notion that there are species differences in response to these treatments. Again, pretty much same figure here showing the plant water stress. And again, just to reiterate, that crucial period of differences really takes place quickly after planting, but the trees can recover following that initial moisture stress. So like I said, the fun thing to me is digging up the trees and really seeing how do the root systems look in response to some of these treatments. We can look at all the above ground photosynthetic rate and growth and all of that, but what do the root systems look like? So after 2 years in the landscape, we went ahead, we take a tree spade, we dig them up, and we can look at the root systems. I have to show this because it's a lot of work dealing with roots, and I had a good crew that, she has a smile on her face. She's not crying, even though she sees all these bags of roots that we need to break down and weigh. And it's a lot of work, but I had a great crew, and I have to give them all the kudos here that we went ahead and broke down a lot of root systems. But what are we really looking at here? Wish this photo didn't have such a shadow, but so be it. I think even if I didn't have these labels, once again, everybody could probably pick out the fact that this is a control tree. Bulk of the roots are continuing to circle in that original nursery imprint. I will say this is a replication of all plane trees. The roots that you're seeing here are from the London plane trees. The shaving, awesome response in my opinion, a ton of outward root growth. You can't see as well, but there's roots growing out the bottom of the, where the bottom layer was removed. We're getting explosion of new roots outward on all sides. Great, healthy looking root system. The bare rooted trees, again, awesome looking root systems, again, compared to the control, much fewer circling roots. However, they're much smaller because, again, we were aggressive and we took out any roots that were circling. So that's where we are really, again, modifying that root to shoot ratio, and maybe seeing some of those potential downsides are due to the smaller root system that needs to still, pull enough water and nutrients for the same size above ground portion of the tree as something of this size with all of these roots. But again, all of this to say that the root defects were certainly reduced in response to the root treatments. I'm going to go ahead and skip this slide for sake of time because I really want to be able to talk about a little bit more here. But this is again showing our percentage of the root system that was still circling. So our black bars across all species are our control. You can see here, I don't know what we're lining up with, but 80 to 90% of the roots still circling. Like I said, the red maple roots were just absolutely dense as can be. So I think that's why the shaving didn't necessarily have a great benefit, was because we're still only removing that inch of roots on the outside, and they were just maybe too far gone at that point to respond super well to the shaving. But if we look at our other species, we're cutting the proportion of circling roots in half. And then again, with the lumping the wash treatments together here, aside from our poor little tulip trees that were all dead, if they did survive, ultimately, there was a benefit and improved root system quality in response to the bare rooting as well. I'm going to summarize everything at the end. So again, in interest of time, I'm just going to kind of fly through our most recent trial because I want to show you where we're going with this. So this here is a wonderful resource I want to make everyone familiar with, from Dr. Nina Basic at Cornell University. I highly recommend looking this up. They've done a ton of work there looking, like I said, specifically at bare root stock. So buying trees that are just, liners, well, not liners, they're grown on to a good size, but field dug without any media or soil surrounding the root system, using those trees to plant urban areas. That's what this whole bulletin is all about. And we're looking through this, and it's got these great lists at the end that show the lists include trees that are easy to transplant as bare root stock, moderately difficult, and then trees that are difficult to transplant as bare root stock. And I will say, I don't show here, but on the easy list, guess who's on there is the London plane tree. That's one that's considered easy to transplant bare root. Looking here, a little hard to see, but on the difficult to transplant bare root list, we have, our friend that was a little more sensitive, the tulip tree. So this led us to want to try to use these lists that have been prepared to maybe see, can we use these lists as a framework to talk about what trees might be better suited to some of these root modification techniques, and which ones may just be too sensitive. That would be on the bare root, difficult to transplant bare root list. So we picked a number of trees off of this list. We went ahead and chose American hop hornbeam and hornbeam, or Carpinus and Australia, and again, the liriodendrons. Those are the trees that we took and we developed our 2021 trial, which is the next iteration I'm going to be talking about. Again, we kept the plane tree as kind of our positive control of something that's just so hardy and responds well to these treatments. And then these three species here, I'm lumping as kind of our difficult to transplant species. And so again, we looked at the control, we did our shaving, we did bare rooting with the water, and then this time is when we looked at that deep vertical slicing through the outer circling roots. And then we also wanted to take a look at potentially using compensatory pruning at planting, which kind of gets people's radars going off because they see that as a red flag. It's been said to not do compensatory pruning at planting. We'll talk a little bit about why we wanted to take a look at the practice. So this was the most recent trial that was established in 2021. So compensatory pruning, why did we want to look at that? Well, again, we saw so much dieback and leaf scorch on these trees that had been, like I keep saying it, but their root to shoot ratio had been disrupted. So we wanted to see, could we kind of preemptively modify the root to shoot ratio or try to bring it back into balance by removing some crown shoot area, if you will, in order to better balance that root to shoot ratio as we're removing so much root area. Should we take off a little bit on the top or the above ground portion? And would we not see as much of that leaf scorch? Possibly. That's what we wanted to look at. And all of this is based on Da Vinci's pipe model theory. We have formulas where we can measure each branch of the tree, and we can effectively take off a standard. We took off a one third leaf area of any of the trees that received the compensatory pruning treatment. So there are ways to standardize how we did that. But all this to say, the compensatory pruning is a little bit taboo now, but we want to kind of challenge that dogma, because again, this was once a common practice. Now, a lot of these people and famous arborists predate me, even before I was born. They knew everything about trees before I was born. But like I said, this used to be a common practice. It was just really shown to some extent to not have much of a benefit, which is, I think, is kind of why it fell out of practice. And then there were other folks such as, Dr. Alex Shigo saying, when you're pruning off leaf area, you're reducing the photosynthetic surface area where the trees aren't going to be able to produce the food that they need. So that's the reduction in carbohydrate production. And then even taking off some of that stem area, you might be reducing carbohydrate reserves for the tree. So that might not be all that beneficial. But actually at the same time, and in the late 20th century, there was research coming out saying that the compensatory pruning might be beneficial for trees that were under water stress conditions, which more and more of our trees, as we experience climate change in a lot of areas, there are going to be more water stress conditions. So this is kind of the background of why we wanted to take a look at the compensatory pruning. So I went ahead again, measured all those little branches of any of the trees that were going to be receiving this treatment, and we pruned those off with help of our researchers. This was done in April of 2021. We went ahead and did the compensatory pruning. Once again, did our bare rooting, took off all that container substrate and pruned the root systems right up. The shaving, we got a little bit smarter, and we bought a electric reciprocating saw, battery operated reciprocating saw, or sawzall, and that makes the shaving go much faster. You do kind of go through a lot of blades, but really saves your shoulder compared to using a handsaw. So again, just remove the entire periphery of the root system. And then the slicing treatment, we went ahead and just did deep vertical, like 6 equidistant deep slices throughout the root system to see how that's going to affect things. So I'm only presenting first year results here. I'm still analyzing the second year, and these trees are still in the landscape. So we're going to continue to monitor them before digging them up, hopefully this fall, fingers crossed. So we'll start to dig these up and see how the root systems are looking. But again, a lot of the initial death does happen within that first growing season, and we can really learn a lot of what we need to learn in the first growing season. So what we're seeing is we have again, on our left, we're calling these our difficult to transplant species. On the right is our positive control, the plane tree. Bare rooting, the bare rooting treatment was the only treatment that had any mortality, and in this case, significant mortality, that the trees died from the bare rooting treatment in our difficult to transplant species. Again, the liriodendrons, really, the tulip trees, if you will, really take the bare rooting hard, and they just might not be a good candidate for that one. So there's a lot of death following planting, unfortunately. The plane trees, the slicing actually was a little detrimental in terms of their survival. I don't know if somebody might have gone a little crazy with their saw and taken out a whole 6th or a whole pie piece when they were doing the deep slicing. I'm not sure. That'll be something, we don't really have an explanation for that at this time, and we'll take a peek at what those roots look like when we ultimately dig them up. But there was even a little bit of death in the plane trees. But the pruning treatment did not affect survival. Now, I didn't clarify this as well earlier, but the only trees that received the pruning treatment was a subset of the control and a subset of those that were bare rooted, because the bare rooting is where, again, we thought we would see most of the dieback and therefore most benefit using the pruning treatment. So nothing significant here statistical wise. However, the trees that did survive the bare rooting, I'll say, more of them received the pruning treatment than did not, if that makes sense there. We did see a little bit of bump up in survival, those that received the pruning treatment versus not, across the board with our difficult to transplant species. And I will also say that bare rooting removed more root biomass than shaving. In this 2021 study, we do collect any of the roots that we remove and we dry and weigh them to kind of just learn more about how much root system we're removing. In the 2018 study, however, the shaving removed more biomass than the bare rooting at that time. So this is going to depend a little bit on how aggressive you're being with your bare rooting, in terms of how many roots you're actually removing, or the weight of the roots that you're removing. But I think that's interesting to note that the root amount of root removal is not necessarily what's causing some of these things that we're seeing. And then once again, we did our dieback rating of 0 being a healthy tree, full tree, no dieback, and then a 4 is dead, a 3, once again, wishes it were dead. And across the difficult to transplant species, the bare rooting is really what's hitting those trees pretty hard at this time. The plain trees, again, they can kind of take whatever you throw at them, other than that little bit of death in response to the slice treatment. However, the bare rooting is where we're seeing a lot of that dieback. And this isn't pulling out those that were pruned. Obviously, this is just averaged across all of the species. And I'm going to go ahead and skip ahead to looking at crown density. We did this by taking photos of the trees and using image analysis software to get a kind of a more quantitative analysis of the crown density. And this is averaged across all species here, but pretty interesting to note that the pruning, because we went ahead and kind of manually manipulated the crown of the tree, balancing that root to shoot ratio, the trees that received the pruning treatment were much denser. Again, maybe not statistically speaking, but pretty obviously graphically here, were much more dense than those that got the bare root treatment without pruning, I should say. So, if you only have 10% crown density, that's a leggy, sparse, sad looking tree, where the pruning may or may not be more beneficial to the aesthetics of the tree. And I don't want to keep anybody too late on their lunch, so I'm just going to go ahead and talk about kind of the overarching observations and recommendations we have. So at this time, we are noting that shaving is a pretty robust method that we've seen to definitely decrease circling roots, improve root egress, which in turn improves tree establishment in the landscape. And there's really not been too many negative impacts, if any, on the species that we've looked at. However, kind of in contradicting that is the bare rooting. It has been shown to be extremely stressful on some species. We haven't done this on every species. We don't have a comprehensive list on who is this going to work for versus not. So the bare rooting can be stressful, and some species are just intolerant of the method. If you want to try these things out, we recommend doing it when the trees are dormant, or at the very least not in the heat of the summer. Like I said, when it's dry and hot. For us in July, we recommend trying this in a season where the trees aren't going to be quite as stressed. If you want to try out the bare rooting, maybe take a look at that bulletin from Cornell. You can just Google Cornell urban forest method bare root, and that bulletin will come up, or I can pass it along. If you're interested in trying this out, maybe avoid those species that are known on the difficult to transplant list. And again, don't do this in the heat of the summer. And then we don't know a ton about the compensatory pruning yet, but hey, there's been no negative impact, and the trees, in my opinion, aesthetically look a little bit better. We'll continue to kind of look at the data and see what's going to come of that in the coming years. And then again, we'll dig these up at the end of the growing season and really see what impact any of these treatments had on the quality of the root systems. So with that, I have a ton of people to thank. I don't do this alone. We have great, funding and helpers across the board. And I hope I left a couple minutes for questions there. So thank you so much.